Let's just talk a little bit about what is this compound, urolithin A? What is it? Where does it come from? And maybe we can create a case for why we all should really care about it.
Sure. Yeah. So, gosh, 15 years of research led us to this journey. So, we started with this idea of bringing the biotech approach to nutrition, sort of the deep dive into foods that have a lot of health benefits. So, we started with the pomegranate. And the pomegranate, as you know, probably has a lot of health benefits. It's, from different ancient cultures, it's been sort of seen as a fruit of gods, etc. So, we started looking into the
It's a
pomegranate
symbol of fertility as well. Yeah.
as well. Yes,
Yeah.
exactly.
Mhm.
Yes, a lot of health benefits. We started looking at the clinical literature around pomegranate juice extracts and really mixed data. And we started looking at all the bioactive compounds. Now, pomegranate has hundreds of bioactive compounds. And so we when I say biotech approach, we actually started looking at all these hundreds of compounds and starting to figure out which one of them was responsible for this sort of superfood status that you get on the pomegranates. And we zeroed in on these antioxidants or polyphenolic compounds called punic-lagens or ellagitannins. These are polyphenols that are found just not in pomegranates, they're found in raspberries and in pecans and walnuts. So essentially all the good stuff in the Mediterranean diet. And we started studying these polyphenols. And what came to, it was actually a sort of serendipitous collaboration with a professor just across the street. We are based out of the Swiss Institute of Technology. We gave him these compounds. In addition, we also kind of added in some of the metabolized products. And now these polyphenols, that once you're taking a glass of juice or eating a bowl of berries, for example, your gut microbiome will harness these, digest them, and release certain other metabolites. And these get into it. And one of them was this compound urolithin A, and we added them into the mix. It was thought initially that urolithin A was basically a waste byproduct of this metabolism through the gut microbiome. And so we gave all these compounds to this famous professor, Professor Johan Ulrichs, who's been basically behind the discoveries of resveratrol and NAD boosters. And he came back running to us saying, what is this molecule? Because none of the other compounds are doing anything, but this one is really extending health span and lifespan of different models that he was working with. And so that started the journey, and that's how we got interested in urolithin A. So urolithin A is basically, for your listeners, is really what I call a postbiotic. So it's the end product of the metabolism of a lot of dietary components that are found in sort of fruits and nuts, such as pomegranate and nuts. And it's really this gut metabolite, this postbiotic, which is what is key for the health benefits of a lot of these fruits and nuts.
And so one of the things that I've heard you talk about is that there is a wide variability in the population at large in terms of their ability to produce this postbiotic. So we're having these polyphenols, and then it really is dependent, as you mentioned, on the gut microbiome to be able to produce this postbiotic. So are there any ethnic or regional areas in the world where we see a better production of urolithin A? Are there genetic SNPs that someone might have or might not have that would predispose them to better or worse production of this postbiotic?
Sure. Yeah. So we have looked at it almost different parts of the world. So we've looked into the French, we've looked into the Canadians, a lot of studies in the US population, US healthy adult population. And it's fascinating. About, I would say in the best case scenario, we see about 30-40% of the healthy adult population shows some levels of urolithin A coming from dietary exposure. Now, some people are what I call blessed ones. They convert very well. So almost 1:1, they'll convert the precursors to the urolithin A. Somebody like me, growing up in India, a lot of antibiotics. Now, I can drink 6 glasses of juice. My body just refuses to make this molecule. And so in
that's
France,
because of the antibiotic. That's the antibiotic use.
Yeah, because of the antibiotic disrupting the gut microbiome for life, probably, and it's very difficult to reconstitute it back to what is the healthy sort of quote unquote the healthy microbiome status.
Okay, so even though you're of Indian status, let's say, or Indian ethnic origin, the use of antibiotics has potentially disrupted your ability to produce urolithin A.
That's my hypothesis. Yeah, because I tried eating all kinds of healthy diets, fermented foods. My body just refuses to make this molecule. And that's why you need to think about calibrated dietary supplementation through this molecule and other sort of gut molecules that are reliant on the gut microbiome, the digestion. So in the Americans, we see only 10, 12%. In the Canadians, it's similar. Now, it may be difference of the food habits of Americans and Canadians versus the French and the Italians, where we see more of 30, 40%. Yeah, that's what we run a study actually in Chicago with 100 people, gave them a glass of pomegranate juice, and we only saw about 30, 40% could convert even if they were provided the right diet. Mm-hmm. Now, back to your question on what is the difference, I think boils down to gut microbiome diversity and richness. And we have tried to study for at least 5 years what is that gut bacteria that is key to it. And in the end, we haven't really succeeded because I think it's just not one bug. It's really the ecosystem because the gut microbiome is so complex. You really need perfect harmony of gut microbiome. So I see this as a postbiotic urolithin A, which also is like a biomarker of perfect gut health. So if your body has the right gut microbiome and you're eating the right diet, you will make it.